Hey everyone, in this video, let's understand one of the next page replacement algorithm, which is LRU, and the full form is least recently used. So in the previous videos, we have already seen our two page replacement algorithms. They were FIFO and the optimal page replacement algorithm. So if you have not watched those videos, please find the link of those videos in the operating system playlist in the video description below, or you can find the link here in the I button also. So you must watch those videos because we will compare this LRU to both of those algorithms. Okay, so that we have the motivation that why do we need LRU. Okay, so let's start. So in the previous video, we have already seen these two algorithms, that is FIFO page replacement and the optimal page replacement algorithm. FIFO is first in, first out, and the other name for the optimal is opt or min. Okay, that we have seen in the previous video. Now, whenever there is a need for the replacement of the page, which page should I replace? Okay, so FIFO says you should replace the oldest page. That means the page that came first inside the main memory. Okay, and the optimal says you look into the future and then decide the page that is not used for the longest period of time. You should replace that page. Okay, so optimal page replacement algorithm actually see the future. Okay, so in the optimal page replacement algorithm, we saw, let's say we have this reference string, okay, and let's say we have only 3 free frames which are allocated to this process. So 1 and 2 and 3, they will be inside those 3 frames, and let's say we are at the page number 4 and we have to decide to accommodate 4 inside these 3 frames, which page should I replace? So optimal page replacement algorithm actually see in the forward direction, that is in this side, and decide which page should I replace. Okay, so according to this, which page should I replace? So you can see the 1 and 2. The 1 and 2 are here. 3, you can see it is here. Okay, so 3 is the page that will be used after a long period of time. Okay, so 3 should be replaced so that I can put 4. Okay, according to the optimal page replacement algorithm. And according to FIFO, which page should I replace? Okay, so according to FIFO, again 1, 2, 3 will be inside the main memory. Okay, they will come one by one. When we are at 4, then according to FIFO, out of 1, 2, 3, 1 is the page that came first inside the main memory. Okay, so FIFO will say you should replace 1 so that you can accommodate 4. Okay, so this was what we have discussed in our previous videos. Now there are some limitations or disadvantages which are related to FIFO and the optimal one. Okay, so we have seen those also. So we saw FIFO suffers from the Belady's anomaly. Okay, and we have already seen what is Belady's anomaly. I'm not going to discuss this again. You can just go to the video of the FIFO page replacement algorithm, and I have already discussed this in the detail. Okay, and the another disadvantage with FIFO was that this algo does not take into the consideration that a page is getting used a lot of time or not. Okay, so let's say in this reference string, let's say 1 is getting used a lot of time. Okay, but FIFO is just a straightforward algorithm. Whichever page came in the main memory for the first time, that is which is the oldest page, that should be just removed or replaced. Okay, it does not take into account that if that replaced page is getting used a very lot of time or not. Okay, so this we have already discussed in the previous video. Okay, these disadvantages I have already discussed in the detail. Okay, so you can watch those videos. And then we discussed the next algorithm, that is the optimal page replacement algorithm, so that we can tackle these problems. But in the optimal page replacement algorithm, there was the limitation that this algorithm is not implemented practically. That is a theoretical algo. That means this optimal algo acts as just a reference, or you can say benchmark, for measuring the performance of the other algorithms that we are going to discuss, or that we have discussed, or that may be discovered in the later period of time. Okay, and why it is not implemented practically? So we saw that actually in real time or in real systems, we cannot predict, or we cannot say, or we cannot see which pages are going to be referenced or demanded by the CPU in future. Okay, we can't say actually future. Okay, so that means if this is a reference string that we are given with, okay, so this is actually a snapshot of a particular time from, let's say, t equal to let's say 1 p.m. to, let's say, t equal to 10 p.m. Okay, these were the different pages referenced. But when we are dealing with the real-time systems, okay, so let's say at 1 p.m. this page was asked, then at 2 p.m. this page was asked. Okay, so let's say at t equal to 2 p.m. this page was asked, but we cannot say that at t equal to 3 p.m. which page which page number will be asked or referenced in the future, okay, or at t equal to 4 or at t equal to 5 p.m. which pages, okay, will be referenced, okay. This is the just the snapshot, because in the real time we will not be knowing which pages can be demanded, right? So yeah, this was the limitation of the optimal page replacement algorithm, okay. This can't be implemented practically, but this was the best algorithm, okay. This will always give the least number of page faults, okay. So if we cannot go with the FIFO page replacement algorithm every time, and the optimal page replacement algorithm is the best one, but it cannot be implemented practically, so we have to go with some another algorithm which can be implemented practically, and which should not have the disadvantages of the FIFO page replacement algorithm, okay. Because at the last we want that page replacement algorithm should work in such a way so that your page fault should reduce, they should decrease, okay. In these fixed frames that are allotted, the particular algorithm should have less number of page faults, okay. We want that type of page replacement algorithms, okay. So if we can't see the future, okay, if we can't see in the forward direction, can we see in the other direction? That means if we are at this point, can we see in this backward direction? Yes, we can see in the backward direction, because in the life we can't see the future, but we can see our past, right? So today we will be seeing our algorithm which actually see in the past, okay, that which page we are going to replace. For that we will be seeing the past, okay, that is we will be going into the backward direction, okay. So let's see which is that algorithm. So that algorithm name is least recently used algorithm, okay. So this is somewhat similar to the optimal page replacement algorithm, but we will see in the backward direction, okay. So let's see how we will apply this algorithm and how it works. So actually least recently used algorithm uses the past knowledge, okay, rather than the future. That means if we are at a particular page, okay, we are at particular page and we have covered all these page numbers, okay, these have been allocated frames, okay. So what we will do at 4, we will see in this direction that out of all these pages, which page should I replace? Optimal see in the future, but LRU will see in the backward direction, that is it will see the past pages, okay. So whenever there is a need to replace a page, LRU will say see in the past, okay, and you should replace that page which has not been used recently, okay. That means you just go in the backward direction and see the page which is actually used very late in the past, okay. That means, for example, here you can see we have 0, here we have 0, here we have 0. So I'm taking this 0 for the example, okay. So let's say at t equal to 1 p.m, okay, we reference 7, okay. Then at t equal to 2 p.m, we reference 0. So what I will do, I will say, okay, I have page numbers, okay, I have page number 0, and I will, let's say, create a, you can say, map or something like, okay, that thing. But while during the example, I will not do this thing, but I'm telling you programming wise, okay. So operating system will keep a track that 0 was referenced at, let's say, 2 p.m, okay. Then at 3 p.m, this was referenced, then at 4, this. At 5, again it was referenced, okay. So its time will be updated, okay. Lastly it was used at 5 p.m, right here. Now at 6 it will be referenced again. At 7 p.m, again it was referenced. So I will update its time, okay. At 7 p.m, it was referenced, 0 was referenced, okay. So the last use of 0 was at 7 p.m, right. So when I will say I am at 4 and I want to replace the page, so I will keep track of all the other pages, okay. I will keep track of the time of all the other pages also in the similar manner, okay. And here you can see the, let's say, 7 have some particular time, let's say it will have 1 p.m, okay, because it was not referenced, okay. Then same way 1 will have some time, 2 will have some time, okay. So these times are the time of the last usage, whenever they was referenced lastly, okay. So whichever page will have you can say smallest number of time, smallest time, okay, smallest time, that page will actually be replaced, okay. So this is the idea behind least recently used, okay. See in the past, and in the past whichever thing I have used very less, okay, or you can say whichever thing I have not referenced recently, okay, you should replace that page, okay. So this is the idea behind the LRU, okay. And this I have told you that with each page number I will keep track of the time that it was last referenced, okay. So in this way this LRU works, okay. So let's see with the help of example how we can apply this algorithm. So here you can see I have taken a reference string. This is the reference string, and this reference string we have taken in the optimal and the FIFO also. Okay, so same string I have taken, okay, so that we can compare it with the other algorithm also. Okay, and the number of free frames that are allocated to this process are 3, right? And we have to find the number of page faults. So let's apply this algorithm and see how it works. So we are given 3 frames, okay, and this is the reference string. Now let's apply. So here you can see for 701, it will work in the similar manner as the FIFO and the optimal works. Okay, so 7 will give me a page fault. Why? Because it is not already present, right? So I will put 7 here and I will write tick. Tick means this has generated a page fault. Now this 0 is not already present inside the main memory, so I will say 0 will create a page fault. So 7, then I will put 0 in this free frame. Then 1, yes, it will generate a page fault because it is not present here. Okay, so I will say 1, okay, and then 7 0 1 should be placed in this free frame, okay, because I have the free frame. So all these 3 have generated a page fault. I have the total count of the you can say page fault as 3. Okay, I can write here or I can later also count. Okay, 3 page fault till now. Now 2, will it generate page fault? Yes. Why? Because inside these 3 frames, this 2 is not already present, right? We have 7 0 1, 2 is not present, so it will generate a page fault. Okay, so what I will do, I will say okay, this 2 is generating page fault. Now the question is, which page should I replace? So LRU says just see in the back direction, okay, and just see out of 7 0 1 which page you can replace. Okay, so you can see this 1 was actually used recently. Okay, this was used recently, okay, just now. 0, yeah, it was used lately before 1. Okay, so it can be removed, but we have 7 also. 7 is the page that was used very long ago. Okay, let's say it is used at 1 p.m, it is used at 2 p.m, and it is used at 3 p.m. So recently, in the recent time or in the recent past, which page was used very least? It is 7. Okay, so that's why I will remove 7. I will replace 7. So 7 will be replaced and I will put 2. So it is 201, my new content, right? Okay, now let's come to 0. So 0 is already present here, so it will not generate page fault. Okay, so it will not generate page fault. So till here I have total 4 page faults, right? Now let's come to 3. So 3 is not present here, so it will generate page fault. Okay, okay, so I have 5 page fault. Okay, so which page should I replace again? So 3 is here, okay, I'm here, so just see in the past, right? So out of 201, any one page should I replace? Okay, so you can see 0 is used just recently, or you can say it was referenced just recently. Then 2, it is referenced. Then 1 is referenced here. So out of this 120, this 1 is the, like you can say, page that was used very long ago in the past. Okay, so 1 can be removed. I should replace this 203. So I hope you have understanding. Okay, so now we came to 0. Okay, so 0 is already present here, so there will be no page fault. Okay, now 4 is not present here, so it will generate page fault. Okay, so my page fault will increase to 6. Okay, and I will see again past. Out of 203, which should I replace? So here you can see 0, yeah, 0 is just referenced. Okay, so 0 will not be replaced. Now we are left with 2 and 3. So you can say here, okay, 3 is referenced. Okay, 2 is referenced very much before 0 and 3, right? So 2 is the candidate for the replacement according to LRU. Okay, so 2 will be replaced by 4. Okay, so 403 is the new content, right? Okay, now 4 so 4 give me a page fault. Okay, now let's come to 2. So 2 is not present here. Okay, so it will give me a page fault. Okay, 7 page fault. Okay, so which page should I replace? So here you can see out of 403. Okay, here you can see 4 0 and this is 3. So you can see, okay, 3 is the page that was used very long time ago in the past, right? So 3 should be removed by this 2, right? So I will say, okay, 2 will replace and it will be new content. Okay, now let's come to 3. So 3 is not here. Okay, so 3 give me page fault. Okay, total is page fault. Okay, so now which page should I replace out of 402? So you can see 2 is used here, 4 is used here, and then 0 is used here. Okay, so these all zeros will have lesser time. Okay, this will have the like recent time. Let's say it is used at 2 p.m. Okay, this is used at 3 p.m. and this is used at, let's say, 4 p.m. Okay, and this will be used, let's say, at some let's say 1 p.m. Okay, so you can see out of 240, 0 is the page which can be replaced because it is used very long time ago in the past, right? So I should replace this 0 by 3. Okay, so 4, 3 and 2. Okay, so total I have how many page fault till now? 8. Okay, so in the same way I can go with the other pages. So 0, again it will generate a page fault. So 0 will come here and I will say, okay, total 9 page faults till now, and I should replace which page? So out of 4, 3, 2, you can say 3 is here, 2 is here and 4 is here. So which page should I replace? 4. Okay, so 4 I should replace and 0 will come, 0, 3, 2. Okay, now 3 will not generate page fault, it is already here. Okay, no page fault. 0, it is already here, so no page fault. 3 already here, no page fault. 2 is already here, so no page fault. 1 is not here, so it will generate page fault, and I have 10 page fault, right? So I will say 1 will generate page fault. Okay, and which page should I replace? 0, 3, 2 I am having. Okay, so I am here, right? So you can see out of 0, 3, 2, 2 is here, 3 is here and 0 is here. Okay, so I should replace this 0, right? So 1 will be here, 1, 3, 2. Okay, now we have 2. So will 2 generate page fault? Here 2 is already here. Okay, it will not generate page fault. 0, yes, 0 will generate page fault, it is not already here. So my total count will be 11. Okay, so which page should I replace out of 1, 3, 2? So 2 is here, 1 is here, and you can say 3 is here, right? So I should replace 3. So I will replace 3 by this 0. So 1, 0, 2. Okay, okay, so now 1 is here. Okay, so 1 is already here, so it will not generate page fault. Now 7 is not here in any of the frame, so it will generate page fault. So which page should I replace out of 102? So 1 is here, 0 is here and 2 is here, right? So I should replace this 2. Okay, because this is the oldest page, or you can say this is the page that was used least, because this is the page that has been referenced in the recent past, but it is used before 0 and 1. Okay, so this is the least recently used page, so I will say 2 should be replaced. Okay, and 7 should come. Okay, so 1, this is 0 and this is 7, right? Now 0 is here, 0 is already here, no page fault, right? And 1 you can see here, 1 is already here, so no page fault. Okay, so how many page faults have been generated? So I think I have missed some counting here, so let's count all these ticks. So 1, 2, 3, 4, then 5, 6, 7, 8, 9 and 10, 11 and then 12. Okay, so total 12 page faults. So with this same reference string, we saw that in FIFO we got 15 page fault, in optimal we got 9 page fault, and in LRU we got 12 page faults, right? So we saw that out of this 12, 15, 9 is the least number. Okay, so as we have discussed, optimal algo always gives the least number of page faults. Okay, but it is not used practically, right? So rest is like FIFO and LRU, and out of FIFO and LRU we got 12 page fault in LRU. Okay, so it is better than 15, right? So this is how our least recently used algorithm actually works. So just we have to take care that instead of seeing in the forward direction in the future, we have to see in the backward direction, so that we can find the page which has to be replaced, okay, according to the LRU. Okay. Now before ending the video, I would recommend you that you use this same reference string and use this LRU and apply this LRU on this reference string by taking total 4 free frames. Okay, instead of 3 free frames, take 4 frames and see that what will be the number of page faults generated. So do tell me in the comment box by writing your answer that how many page faults you got after you took 4 frames for this reference string. It will obviously be less than your 12. Okay, when you increase the number of frames, you get less number of page faults. Okay, and LRU does not suffer from any Belady anomaly. Okay, so you will get less number of page faults when you increase the number of frames in LRU. Okay, so you may be wondering that why LRU actually sees the past. So actually it is assumed that past is the better predictor for the future. Whatever happened in our past, it can be like a better predictor to predict what will happen in our future. Okay, so on the same theme, LRU says that whatever pages have been used very least amount of time in the past, they will be used very least amount of time or for very less number of times in the future also. Okay, that's why those pages are the better candidate for the replacement. Okay, and we can see the past. Okay, that's why LRU is using that assumption. We cannot see the future, that's why we are not using optimal algorithm. So yeah, this was all about this video. So please like and share this video and subscribe to the channel and press the bell icon for further notification. See you in the next video with next example of the LRU. Okay, so till then, goodbye.